If you start anywhere, some of these have two cars that go to a station. I don't care where you start, but if you'll go clockwise around the room till you've seen them all. So just turn them over and turn them back when you finish, just so they can see the next number. But you start anywhere, just remember where you start, okay? And this one we're not going to do. I'm just going to take that one off. But number one's there, but you don't have to. My name is Midgett, and I'm working with the Science Olympiad. I'm out of the office in Raleigh, which is connected to the Science House at North Carolina State University. And today we've been working with Onslow County elementary coaches to do things like build catapults, airplanes, and go through some of the rotation events like SkyQuest and weather permitting the rest of the time. Because once you start building, it's hard to quit, okay? We'll do SkyQuest in a minute. This is a rotation event. It's going to vary by regional, and you can decide to do, like Michelle said, you can decide to make this as rigorous or as long as you want to be, and you can even change, not you individually as a teacher, but the group. Whoever sets this up for you will decide if the station's kids should be there 2 minutes or 3 minutes or whatever. This one. Now, there is another way to do rotational events. I need to tell you that way in case it happens to you. Like, for example, let's say weather permitting, whoever writes the event, they might have some things that they want the children to do at their seat and stay there a while, interpret some things and look at some maps and not have to be rushed with the 2 or 3 minute rotation. So let's imagine you had an hour for this event. It might be that they would be seated for 25 minutes doing something. Half the group might be, let's say over there's the lab part, half the group would be in groups or pairs or whatever doing 25 minutes. And while they're doing that 25 minutes, the other half would be rotating for 25 minutes. So they might have, say, 12 stations or something like that to do 2 minutes apiece or something. And then they'll switch. So it could be that way. The way this one you've seen here, they're all supposed to be the same length of time. They would be told what that was. It might be a minute and a half or 2 or 3 or whatever. And then the person's going to say rotate, and they have to go to the next station and answer the questions there. And they usually have an answer sheet that travels with them, the pair does, and they stay together. They don't split up. That your pair of students stay together, and then they go to the next one, to the next, until they've done all the stations. And like Michelle's saying, if a station gets, I tell the children, this is something good to tell them. If you get to a station, any station event, whether it's this one or another one, and you get there and you're reading it's talking about something that's not there, and you think it should be there, it looks like it should be there, it's implied that it should be there, raise your hand and ask the event leader. Because what happens, I don't want to be unfair to your children, but let's suppose we're doing this for real, and you move from 17 to 18, but you take something with you inadvertently. You don't really mean to, but you got it in your hand. And so you're here with it, and the kids are there, and they get there and they go, I don't understand. Well, by the time they figure it out, rotate, they got to go to 18, so they're going to miss that one automatically. So if you tell the event leader will say stop, find out what's happening, put it back, and then give everybody the right amount of time so your kids won't be slighted. But if you don't know to say that, tell your children that if they get there, they need to raise their hand and ask a question quickly. If they think there's an instrument missing or a chart or something like that. Like, for example, this one has 2 pages. And so they're going to turn over both pages. Here's some questions and here's a picture. The kids could be looking at it, and next thing you know, they've walked off with the pictures. And so we got to keep those together, that sort of thing, okay?
We always tell the event leaders to make sure that if it is a rotation, especially in some of our classrooms where they're having to get up and to move to the next one and then back, it starts off a little slower and then they get into a routine. It is not an automatic thing that we expect the student to know exactly when to rotate and where to go and so forth. It is something, I was an event leader, so with a 25 station event. So just letting you know, your students are not thrown in and expected to know what to do in these events. Because, I mean, it just doesn't happen that way. And there's always 2 to 3 people who are in that room. So you have somebody at the front doing time and up to 2, sometimes even 3 helpers in the room assisting students in moving to the next station. So because we do have students who are, I mean, in first grade, you know, sometimes, so it's a little difficult, but I mean, everybody gets up and moves. Usually after the 3rd rotation, everything is good. The kids get it. So, and we do monitor time. I mean, so we just make sure everything is, I mean, it's equal, it's equitable, and so forth across the board. And the question was, again, and I'll keep stating, when I walk through, and then there's a couple of event leaders that I will call in, and we will actually gauge whether the number of questions is appropriate. and then we will take questions out. We really will, because a couple of, it just gets to be a bit much. They do need time to read, they do need time to think, but they don't need 5 minutes per question. It is a science Olympiad, so what we're talking about is they need to be able to get it, but not to be too stressed. It's not about stress, it's about the fun. So we're putting out another one. So the one that you just did was weather permitting. For each school, I have one colored set, so you can take back with you, and you can actually use. And one of the things, like Emily said, was to make sure when you're pairing the kids, a young one with an older one, and that's perfectly acceptable. So, know who you're, putting together. If there are words, especially for our younger ones, we will know, the grade and so forth. I am more than happy to, if they don't know what the word is, we'll say the word. It's not that big of a deal. We will not explain the word. Okay, we cannot do that.
And I suggest, like an event like you just saw, or even this one, you might pair an older student with a younger student. The tendency might be to put 2 fifth graders in there. I put a younger student with an older student because that younger student will be the older student next year. That would be, a lot of times the event's the same. They will have seen the event, they'll be confident, that sort of thing, but there's a tendency to put them by the same grade level, 2/4 and 2/5 and things like that, but I would mix them a little if you could. And the goal is to have a fair test, like Michelle said, a fair test that would be let students, in other words, I'll have to tell you, I was the Olympiad director for 23 years for the state, and I never did elementary Olympiads like this, regional ones, and the reason I did not was because of the competitiveness of it. And so what I did do was go to schools and get hundreds of schools to do Olympiads, but they did it within the school. And the idea was, and actually it's the teaching philosophy I would have with Olympiad, not that we're going to go beat somebody, but I'm going to get better myself. I'm going to build something that's going to get better and better. I'm going to learn more about this subject. And so they're kind of competing within themselves to some degree. And I always like to do that. And I've had a lot of success with students doing that over the years. I taught 1st grade and 5th grade, and I did a lot of things with my 5th graders. They were Olympiad kinds of things. But now that we do these, and they are somewhat competitive, it's like when kids go T-ball. When they do T-ball the first time, they have a good time, and they don't even know who won. It's kind of nice, They just had everybody had a good time. It didn't matter who won or lost. But when you get to middle school and high school, they start getting really competitive. And the parents are probably a lot more competitive than the children. I hate to say it, especially the dads. So anyway, we want all the children to have a good experience. We want them to see a lot of things that they feel good about. Oh, I answered that. I knew that. I learned that in school. And they can show what they learned. And there should be some, since they do have it competitive, that are going to challenge them. They're going to be very difficult. Some are going to be better at it than others. We don't want kids to come and just hate it because they couldn't answer anything. So there should be a lot of things that will be familiar to them if it's been taught this year. That's why you should not throw a kid in there that hadn't practiced. A lot of times that happens. Lots of times we'll go do that. And it really stresses the kid out because they want to do well and they get into an event they haven't practiced and they fall apart. So hopefully that won't happen, okay? Hopefully they've practiced, they've learned about it, and they feel very good about it. And pair them up, carefully choose your pairs if you can. Now, you've just seen weather permitting, and this one's SkyQuest from last year that was used somewhere, or a lot of SkyQuest that was used. So if you want to get up and look at this one, and we'll get these 2 rotation ones behind us. If you go the same direction, come around as you're looking down the room, go clockwise like this. Just since they give these to everybody, they're not going to use these questions.
I have to say that.
They're going to ask about these things, but they're going to have to ask different ways. You can take a question out of context. Let me tell you a question. It's really an easy one, but it's made hard by the way we learn science. If I were to ask y'all that when a person exhales, so this is one of the body events, when I exhale, what's the gas that I mainly exhale? Okay, how many say carbon dioxide? You're worried about it being true, but I heard a lot of carbon dioxide, right? That's not the answer. Because what we do when we learn in science, we only teach a piece of the picture. We teach respiration, and we teach photosynthesis, and so we teach what plants need and what they put off and what we take in, what we put off. But we breathe out carbon dioxide, yes. But mostly what we breathe in is what?
Nitrogen.
Nitrogen. 78% of what we inhale is nitrogen, which we do not use. So we exhale that. So a large percentage of what we exhale is the nitrogen we did not use. And then we exhale a little bit of oxygen we didn't use. And then we exhale carbon dioxide that was converted from all those processes. So the kids get the false impression that when we exhale, we're exhaling carbon dioxide all the time. Yes, we are. but that's not the majority of what we exhale. So that's just one little question. That's a hard question, isn't it, when you think about it? Because they're all going to say carbon dioxide right off, right? The reason I said that is there are a lot of things in this event that if children are told and they memorize it, they're going to do okay. But if they know how things work, the relationship, like the phases, they could ask them to name the phases. That would be easy. That's memorization, right? But they could ask them, which alignment would the sun, earth, and moon be when you see this phase? If the kid answered that, you would know they knew the alignments. And usually the objective says the kids would understand the alignments of the sun, earth, and moon and the cause of the phases. So if you got first quarter moon, if I put the sun here and the earth here, where would the moon be? And they got to know where the moon would be here. They got to know that to answer that question. But to answer that question, they would then fully understand the motions. So somebody might ask them questions like that that go beyond just memorization. And the only way they're going to get those right is to kind of know how things work a little bit. Like the constellations this year, there are a lot of constellations in there. They might recognize, if somebody gives them a picture of each constellation, they might recognize that constellation. But if they might ask, where would you find the constellation relative to others? They'd go, I don't know. They've never looked at constellations. And when you teach constellations, usually you teach how to find one based on where another one is. Like if you go to the Big Dipper, it points to certain ones, the Little Dipper points to certain ones, so you know where they are in the sky. Why do you see certain constellations part of the year, but you don't see them the other part of the year? Why would that be? Do y'all know the answer to that one? Huh?
Earth's rotation around the sun.
What?
Earth's orbit around the sun.
Yeah, the orbit. You said rotation, though, didn't you?
Oh,
Yeah. Revolution? What was that?
Just the position of the sun to the earth.
Yeah, we're on the other side, so it's daytime now. There are constellations out there all day. But we can't see them because the sun's in the way. 6 months later, we're on the other side of the sun, and when we're facing that same direction, it's dark that direction, and we can now see the constellations. But and then there are others we can't see. So just to understand that helps a little bit. Okay. So they need to do more than just memorize things. Memorizing helps. This is an event where memorizing, they'll go a long way. But if they learn how things work, they're going to go far. Okay? Any questions with the, again, I don't know if I can answer all the questions, but this is a sample. And like Michelle said, they're not going to ask you these exact same questions this same way this year, probably. Yeah, we're going to build some catapults. Let me show you some catapults. You don't have to build one like these. Here's one. If you don't mind, I'll try to move around a little bit, different places. But can you see okay if I put it right here on the corner of the table or this place? Okay. You can get up if you need to. This was kind of illegal for 2 or 3 reasons. But there is going to have to be a change, and Michelle will be up on the change when we do it. We're going to have some kind of slight change in the rules. There's a piece in there that says no metal. I think we're going to allow some metal, have to, like down here, hinges and things like this, maybe something here. And here, this probably should not be metal. Anything that's up here near the end of this arm that's going to fly should not be metal. Like this should not be a metal screw here on that. This should not be metal. This part should. Now, right now, none of it should be metal, as of right now. But I think we're going to have to allow metal this year. So look for an update on the event in relation to use of metal. But the difference is, I did this at Marbles Museum a few weeks ago. We had about 500 kids made catapults in the same day. Just came through as soon as they came in to start building a catapult. But there's a big difference. They didn't have to trigger their catapult by touching it. They could just hold it. That makes it a lot easier. So when you teach the children to make a catapult, I would make a simple catapult first that didn't have a release button to start with. And we'll show you how to build those. In fact, we'll build those first in a few minutes. We'll build one of those first. But this is one with kind of a release mechanism. You can see it's got lots of rubber bands. A lot of things wrong with this one. Not only the metal, which I think we should say none of that should be metal right there. But this will be okay down here and down here. All right? They got rubber bands on here that have twisty ties that are permanently on here. So if these rubber bands break, it's going to be hard to replace them. So they need to have some way to add and take away rubber bands. This one, they did learn something with this one. When the kids first make a catapult, they'll make one they want to launch something a long ways. And they don't realize they need to stop this arm. And some of them, let me show you a different design. Some of them look like this. And if I had a catapult, this one's been damaged, this one's been through the wars, but if I pull this one back, one thing good about this one, it had a release mechanism because it's got a mouse trap on it. So when you pull this one completely back and you set the mouse trap, you could kind of set it like this. It's kind of messed up, but when you set it, you could trip it, and it did that. So at least it has a trip. But when they first made this, whoever made this, the kids, they did not have this string. So when they pulled it back, they were so proud. They had this thing, they pulled it back, and when the string's not on there, it just goes, bam, and throws the marshmallow in the floor right there. See, it never throws a marshmallow out there anywhere. It just, bam, right in the floor. And so yours are going to do that. Let them do that to start with. One thing I tell parents that come in to help students with Build It events is, don't tell the children how to build it. You're there to make sure they're safe and they kind of follow the rules, but don't say, you need to do this or you ought to do that. You might ask instead, well, why are you doing that? Or how are you going to get it to do this? Or how are you going to overcome this problem? Because you want the children to think when they're building. If somebody comes in and just tells them how to build it, I see that all the time with middle school. And I hate to say it, I see a lot with middle school girls when the dad's overbearing. They'll show up at the event, like I run a lot of the car events and whatever. I run one like a Rube Goldberg event at Mission. It's called Mission Possible, where they build this big machine and all. I do that nationally and with the state. But when I do the car events, many times I've had a dad there, and the two girls will come up and put their car down on the table for me to do all the measurements and make sure everything fits. So I'll start asking, where's your bumper, or where's your fixed point, stuff like that goes with the car event. And every time I ask the girls a question, Dad answers the question back over there. I said, whoa, wait a minute, who's in this event? I said, let them answer the questions. And so then they can answer the questions, we get through it. And then when it comes to running it, Dad has domineered the event so much that they don't even know how to adjust their car. So if they run it, if they have two runs, if they run the first one, it doesn't do very well, they look up and they're looking for some help. But they aren't getting it because we don't let them. The children have to do this. So they don't do very well. So be cautious. You want parents to come in and help with the construction events, but they shouldn't just tell the children what to do. And they need to let the children launch it and play with it and do all those things, not just a bunch of the dads over there doing it. You know, you see that sometimes, okay? So with that, ask lots of questions. So here's one design where they use a mouse trap, and you can use a mouse trap. I don't think a mouse trap will get your long distance launches very well because it's only so strong. They could hook two mouse traps up, figure out a way to make two, but really two mouse traps together aren't twice as strong. It performs about as good as with one. And so I haven't seen mousetrap devices that will throw it. What's your maximum distance it can go this year? Yeah, look at your rules. Yeah, maximum. The range of distances that they're going to tell the children when they get there how far they need to shoot at a target.
5 meters.
What is it?
5 meters.
5 meters. Okay? Which is a little over 15 feet. 5 meters. Where'd you see that? What letter is it? 10 what?
10C.
10C? Okay, everybody find 10C? Now, I'll have to tell you this. I see this all the time with middle school children. The teachers I know how hard it is. I taught for many years. I just retired from the state last year. Give me a hand, you know. I just retired from teaching after 35 years. But it's hard with all you do in the school day and all that you're responsible for, and then you're doing the Olympiad events, you got a team, and there are about 19 different events. It's so easy to ask the child, and you trust the child, they're trustworthy and they're good kids. You say, now, did you read all these rules and you followed all of them, right? What's the kid going to say?
Yes.
Yes. No matter what, they've got to say yes. And they really believe they have. But the first thing is when they set their device down, we start measuring, looking at it, there'll be a violation. Now that really dashes the kid. That really is terrible. And then you feel like you got to defend them and all that kind of stuff, or the parent does or whatever. But it's maybe clearly right there in the rules, you can't do this, you got to do that, it's got to be a certain length. We see that a lot in events, especially rocket, 3-2-1 blast-off events like that, where they don't follow some rule in there. And those rules aren't in there a lot of times to stump them. They're in there to make the event different each year, so it'll be a challenge and also be safe. So please make sure, if you have a score sheet, which we do have today, Michelle gave you a score sheet, one way to check it is to take the device and have another child, another team, let's say we built 2 different devices, we switch, I'm going to go through the score sheet and see if yours meets everything before we even perform. And they may find a violation that they can correct. So you want to make sure, because I really don't want children to get to the event and then they got something, they violated something. And it would be nice to say, okay, you can just go ahead. Well, then it's not fair to all the other ones who didn't violate something, who followed the rules. Because I can tell you, Murphy's Law will bite you if you're an event leader and you allow, let's say you violated something a little bit in your rules. I say, well, it's okay. It's okay. Go ahead and perform. You're going to win. Now what am I going to do with it? All the other 15 schools are going, wait a minute now. We followed the rules and you let her through and she won. It's going to always happen. Murphy's Law is going to jump up and bite you if you let something slip, which you shouldn't do that. We don't want the children to be dashed. But they got, like if it has dimensions or whatever, they got to follow, it's got to be within the dimensions. 2 shots, do you shoot it twice?
Yeah, I am.
There are 2 shots.
Yeah.
But
Yeah, it says half-meter increments.
half-meter increments. So from 1, it's got to go from 1 to 5, right? So they should make their device and practice. And that's where some of the children want to just make it, but they don't want to practice. At least it's not far out there to go get a marshmallow. So they need to launch it so they can hit a target at 1 meter, 1.5 meters, 2 meters, 2.5, 3, 3.5, 4, 4.5, 5. They need to have all those distances. I have a little book recorded, and they need to write down how they change their instrument to make it go those different distances. I'll show you how to make it go different distances in a while with some of with these and some of yours. These aren't good ones. They're kind of all broken up now. But like this one realized that you got to stop this, because if they didn't, at least this one can't flop over like this one does without the string, just flops over. This one's going to at least hit that board, and so it's going to throw the marshmallow out there a little bit. But for a short distance, if I always pull it down and just let it go, it's always going to launch a marshmallow the same distance. So I had one a minute ago. Let's just look at, it may not be good. And also, the thing holding the marshmallow here is not very good. I'll talk about when we leave today, and I won't hide it. I won't tell one person, I need to tell you this because you could win. No, I'm not going to do that. I will tell everybody good design things you can do. I'll tell you that today. But this one, the cup that holds the marshmallow is not very good.
It's called a
Thank you. All right. So let's just put the marshmallow here and see what it does. Oh, I almost made it in a trash can. I didn't even aim, but that would have been good. That would have been really good. I should have aimed a little bit, but that's about as far as that one will go. And that's probably 5 meters. But if I want that to go 1 meter, I got to do something. And so what they decided they could do on this one, and the kids, this one works the same way, is they got this chain here that they can hook in here. Let's see, maybe not that one. Yeah. And you can hook this chain at different places, different lengths on the chain, okay? Let's try it this way. Like this is not very far. That wouldn't launch it very far. But right now, it's a bear to get off. You can't just knock that off with a pencil. You know, and so what I would do is, what they did on this one is, see if they did it. They missed a little bit. See these 2 loops right here? There are 2 loops right here on the back, 2 rings like that sticking on the very back of this. If they have a loop right here on the bottom of this that matches those 2, they could push it down through them and stick a rod in there. And then when they pull the pencil out, it does that. See? Okay, let's try the same marshmallows. Let's see what that one does. And so this one, they still got the rubber band. They still pull it all the way down, but they don't let the arm go as far. So let's see what this one does. Shorter distance. So what they got to do is play with the length of chain to get it to go all those different distances. Now they're measuring from the front of the device. So they put this at the start line, and they measure the target's going to be out there. Of course, they also got line at what's funny. It's not funny, haha funny, but kids will go to all this trouble and get everything right, and then they won't aim. They'll be in a hurry and it's like in middle school. That event I was telling you about starts with you dropping something in the device, and this year it's a racquetball. They have to drop a racquetball in the device. And so middle school kids get so nervous, they'll go, all they have to do is this, 1, 2, 3, go. To start it, they have to drop that in the device. But I'll say, 1, 2, 3, go! And the kids will just, all over the place. I had one kid, we were doing quarters one year, had a half a roll of quarters before he could drop one. All he had to do was so nervous. So they should be relaxed and practice all the time. They should know how far that's going to go. And you could see that if they had a loop there and put a rod in there, they could pull that out, and that would fire. Now keep in mind, we're going to let Michelle know about metal we're going to have some kind of clarification about use of metal, because this one has it. And I think they should be allowed to use some metal. We just don't want a piece of metal flying and hitting a child. Because if you can imagine, if you're out there. It's not so much at the competition. It's back when they're at school practicing. Here they are in the school, you're doing all kinds of stuff, and they're practicing all over them. Next thing you know, somebody's whacked somebody with one of these things, okay? So here's one. This one, you can see what they would do with this one is they would vary the length of this string also. And there's a nail here they can wrap it around, and they can knock it off the nail, or they can have it on the nail when they trip the device. So it could go like this, wouldn't go as far, or they could have it a little further, where when they pull it down, let go of it, it goes further, and so on. Okay? So these are adjustable. And so today, the one you're going to build, the first one you're going to build, don't worry about starting it with a pencil today, the first one. And you can use a mousetrap to power your device today, or you can use rubber bands, or you can use the elasticity of a solid, which neither one of these really does. Let me show you that one. Here's the one like the kids built. This is a large one. Well, let's use this one. Here's one like the kids built at Marbles. And I'll pass this around in a minute. Basically, they didn't have this board. I've taken this stuff down now. All they had was 2 paint sticks, like from Lowe's or Home Depot. Kim told me to tell you she drank a lot of wine to get you all these corks. All these, and you appreciate it. So you have a wine cork here, and you can use something else, an eraser or something like that, but it needs to be something kind of round and firm. But there's a wine cork here, and there are rubber bands on the very end of this thing holding the 2 paint sticks together on the very end. And then there are rubber bands right here that hold them together tight. And the way this one works is there's a paper clip here that's wrapped around a string on the bottom one. If I push this off, it does that. This one's not real adjustable, but these will launch a marshmallow sometimes a good distance. But you'll find it's something really fast when you make one. Now remember, the kids didn't have the board when we were making some earlier. So watch what this does when I launch the marshmallow. I'm just going to pull these together and let go. I'm just going to probably hit it straight up. Not bad. That's like 2 meters. But if I want to go further, the kids found out that if they want to go further, they need to fix this thing where they can tilt it like that. And they might be able to get the marshmallow to go out there further. Also, they can vary how far back. They pull this, and also the tilt. But right now, I'm just going to pull it all the way down again like it was. And so I got another. That's like 4 meters. So you only got to go 1 more meter. Okay? So this is a good design to build, and you can also see how to release this one. So they might tilt at different angles, and you're all going to have marshmallows at some point. And I think Michelle even said there's enough that if you want to eat one, it wouldn't be a crime. Just don't eat the one that's been on the floor. Eat a fresh. We'll tell you where the fresh ones are. But I want you to make one. So all the materials are here. Let's distribute the materials. We'll put them out on the table. You can get what you need. We don't have a lot of boards like this today, but you can tilt. Today you'll be allowed to tilt them up without a board if you need to. But I want you to at least first build this one, and we'll see how far we can build in the time we have today.
Part 9D.
Okay.
What part of the catapult is allowed higher than 60 centimeters from the floor when the launch is triggered?
All right. I measured this one, so that's 60 centimeters. But if you made the rod 60 centimeters, then you put it on a board this thick,
Right.
then it's higher than 60 centimeters from the floor. Because it does say 60 centimeters from the floor. This one has no problem being 60 centimeters. That one, even if you tilt it, has no problem. We can measure today and see if there's 60 centimeters. Okay. It says no part. No part. So this would be the highest part, or that would be the highest part. But this is the highest part of this one. So right now, this one I think is illegal because this is 60 centimeters plus a few more, about 4 or 5 more. And if it's tilted, it's even more. But if you tilt it, it'd be even higher from the floor. Okay? So that's a good point to point out. Okay? You ready to build some?
And then the marshmallows that we're launching, will we know?
They're going to be just like that one. They're not going to be the minis. They won't be the minis. And now marshmallows come in that big old glob-looking one. They aren't going to be those. It's going to be the standard, regular, old-fashioned marshmallow size, that one. If I can do it without breaking them. So now it ought to be a little harder to hold. Let's just see. I just add 2 rubber bands to it. What I do with the marshmallow, I've already thrown it away. Watch me step on it. There you go. I'll get another one. All right. Marshmallow number 2. We'll tilt it like we did before. So, yeah, I'm trying not to break your phone here before the day's over. Okay. We got about 1.5 meters further just by adding 2 rubber bands. So you see how you make it more powerful. I just made it a little stronger right here so when it recoiled, it pulled it a little harder. Okay, so there you go. We got these for you. I'm trying to steal your stuff today. Phone, I got your phone, I got your briefcase. So come get some stuff and let's build one. You can build one yourself if you want. There's your big one. Don't have any little ones today. This is what she gave me. They're mouth back. Well, you can actually take one for sure.
You can take them home or just borrow?
You can take one home. You can take one.
Yeah, I can take
one. You might want to get a few.
Well, just
be fine. We wanted that loose. Maybe we should have done this one first and then opened it up and tightened it.
Because we're gonna put them on the
I don't know. See what it feels like.
Okay, so do you want to hold that together and I'll start on this end?
Anybody needs a clothespin, let me know. Got clothespins out there. Yeah.
Oh, I should have gone to the inside first. But do we want to put one on the inside here?
You need to help her, sir, what to do, okay? I should have been at storage.
See? Need some like this. Would you do that first?
Yep.
Better use one of those.
Yeah, before putting the spoon, I put one here.
Aquapod. All right, what you got now? Let's see how she does with hers. Here, come on. Hey, all right, Bill, what do you do there? They come over, they got 5 minutes, they're told the two distances. They launch at one target, the first target, and then the distance is measured how far they are from the target in centimeters. Then they launch to the second target, and that distance is measured. They add the two measurements together, and the lowest score wins. So it's the lowest overall score. They could be very close to one of them and way off far on the other one. But they really want to be close on both of them because it's the lowest total that wins. Now there's another, I'm going to pick one rule. I'm going to pick 9C. Let's suppose at your competition there are 16 teams, but 5 of them violate 9C. That's the one where you got to have a trigger to activate the arm. So 5 of the devices, they haven't figured out how to activate it. They got to hold it themselves, which you're not supposed to be to do. Well, those are put in what's called Tier 2, those 5. That's a whole tier below the others. So the other 11 that met all the qualifications, they're going to compete, and those 11 are going to come in 1st through 11th. That other one, of the 5 that didn't qualify, they're in a tier. The very best one could have the best launches all day and have the best score all day, hit both of them right on the button, but they're going to come in 12th because they broke a major rule. Now, they'll come in first among those 5. So they're in a whole group together. It's like they put them in different groups. So all those who meet all the qualifications, they're in the top group. If they break any of these rules, 9A through H, then they're put in another group that's going to compete all together. So you see how they might have a really great one, but they've broken a rule. That's why you don't want to break any of these rules. You'll be put in what's called Tier 2. Okay? It says no part of the device will be allowed to leave the catapult during the launch except the marshmallow. So if they fire it and something flies out there in either launch, they're going to be put in Tier 2 if something flies out there. Okay? So keep that in mind. And unfortunately, if a rubber band breaks and flies out there, that would be something flying out there. The students, they're going to build an airplane on the spot. It tells what they can bring. They can bring a pair of scissors with them and things like that. But they'll have tape. The main things they can use are tape, scissors, and paper clips, other than the paper. You can have one plane, and each student can launch their plane. Or you can have 2 planes, and each one launches their own plane. And let's look at the scoring now. Determined by the teams, the sum of the final distance and accuracy scores after the accuracy distance are deducted from the flight distances. I'm going to explain what that means in a second. So both of them count. Last year, it was the longest one. They threw one. If one went for like 30 seconds and one went for 1, it was the 32nd one. But this year, it's going to rank determined by the sum of the final distance and accuracy scores. So both flights count, and both people are throwing this year. So you can't put the athlete out there with the other kid who can't throw. Now, here's what it means by accuracy scores. Let me show you that. And I have a start line right here. It's a start line. It's going to probably tell you there they can't get a running start. It's probably going to tell you they kind of have to just stand and throw.
2 feet on the ground.
Right. Okay, so they have to do something like that. And the best thing to do, truly, is see if they'll let you do that, like a baseball player would, where they got 2 feet, but they do this, take that, and they don't, and both feet are on the ground when I throw, but I don't run. That gives my body a little throwing momentum. That's the easiest. You can do it without it. You can actually do this. A little harder to do. If they're really coordinated, this is the best way to do it. Okay? Now, So let's say you throw your airplane. And you throw your airplane, and your airplane lands right where this little white spot is. Right, see that little spot on the floor? So here's what they're going to do. They're going to pull a little string, a piece of string, from this spot straight to the tape to where it's perpendicular right there. And then they're going to swing an arc, and that's your distance right there. So what they're doing, they could measure that distance that far and deduct it. That takes a lot longer. So what they could do is, like right now, if you threw it that far, I'd say, well, it's that far, right where the tip of my toe is, right there. But then I'd measure that distance and deduct it. That takes a long time. We've got a lot of kids there. So what they're going to usually do, if they do it right, is they'll pull a piece of string straight at the tape. The string then is held, so it's tight. It doesn't change length. They swing it back toward the start, and you deduct that distance. So if you land over there, like let's say you land right here. They pull a string from there, right straight to the tape, perpendicular, swing an arc. You'll get some kids get minus scores if you don't watch out, because they'll throw from there, it'll land over here. And so this one will be pulled straight to here, a string, swing an arc back there somewhere, okay? So they do need to throw it down the course. It needs to be accurate down the course, and it's going to be deducted. The distance they are off is deducted from their length. So that's how they determine the score, both flights. So they don't need to get up there. Some kids will get up there, it's like after all year, they get up there and go and just throw it. Don't even hardly look where they're doing it. They need to be real deliberate about it. They need to look right down the line and throw it. And I have to tell you, these are tips for everybody. When they throw it, their arm needs to go in the same motion as right down this line. Unless their plane does something funky, like always curves to the right or something. But they're trying to throw it straight, and they're right-handed. They need to be at the line so that they throw it right down the line. A little straighter, and the paperclip jumped off, a little straighter. I can make the plane twirl too, which is good. It won't.
Get up here, it works better back there, but for some reason.
That's what this one does. No, I changed it. That was a bad change. And change your plane and then see what happens next time. That was pretty straight.